So we're going to get the graph of sine and cosine. We're getting these from the unit circle. We're using those decimals over there. We're going to move a little bit faster with this because this should already have been done. So cosine, remember, is the x-coordinate. So our x-axis on this graph is the angle measurement theta. And the y-axis on this graph now will represent the cosine value. In other words, the x-coordinate of that point. I'm going to close that. So at 0 degrees, what's the corresponding cosine value? In other words, what's the x-coordinate at 0 degrees? 1. So that's the point. 0, 1. And pi over 4. The cosine of pi over 4 is, oh, you know what, I skipped over pi over 6. At pi over 6, the cosine of pi over 6 is 0.9, the radical 3 over 2. At pi over 4, the cosine value is 0.7, the radical 2 over 2. Notice they're right on top of each other, which should not surprise you because sine and cosine equal each other at pi over 4. And pi over 3, the cosine value is 1/2, 0.5, good. And then at pi over 2, the cosine value is 0. Can anyone guess right now the relationship between sine and cosine? Yes. Yeah, it's that graph moved over. So if you took the sine of graph of sine and moved it over pi over 2 units to the left, you get the graph of cosine. Or you can say take the graph of cosine, move it pi over 2 units to the right, you get the graph of sine. We're going to prove that algebraically in the next chapter, but we're seeing it visually. So I'm going to give you the rest of the points here. 2 pi over 3 should give you negative 1/2. 3 pi over 4 should give you negative 0.7. 5 pi over 6 should give you negative 0.9. And pi should give you negative 1. So, filling in this section carefully, awfully. That was good enough. Now, we did not finish either of these graphs past pi, but technically what's going to happen is it's going to pop back up here. And let me finish off sine 1 right here. And sine is going to oscillate down here. Keyword there is oscillate, meaning jumps back and forth. And remember to do the negative versions. You're going to do the coterminal angles. As it turns out, the graph of cosine is symmetric about the y-axis. That's going to prove something algebraically for us later on. We'll just fill it in as we go. Oh, sorry about those points being off. So the graph in red here is the graph of cosine. And again, it technically would bounce back up, just like your graph of sine would bounce up. So speaking of these oscillations, in red here would be the graph of cosine. It just keeps oscillating back and forth. And the one blue that we drew before was the graph of sine. So what we're going to do in the next section is simplify this even more, because as it turns out, you just have to know where's the top, where's the middle, where's the bottom. Because then once you have that, it just keeps, well, not to use the word again, oscillating, going back and forth. So that's comment number 1. Comment number 2, since these are both basically the same graph, just shifted, all you have to know is where they start. Notice sine starts at the origin, And cosine starts at what y value? 1. Okay? So if you know where the middle is and you know how they oscillate, you can do the entire graph. For both sine and for cosine.